I'm going to explain how to maybe think through practice 4. So number 1, it says a bicycle is moving at a speed of 5 meters per second. So 5 meters per second, this is our velocity. Okay, how much time does it take him to travel 15 meters? This is not our position. Well, I mean, I guess it could also be our position, but it's really our displacement. Okay, or our delta x. So what I'd like to do first then is fill out my graph, my position time graph for A. So at 0 seconds, he was at 0 meters. At 1 second, and then it says that he was traveling. We don't know how long he's traveling, but he was going at 5 meters per second. So that means at 1 second, he had traveled 5 meters. Then at 2 seconds, he had traveled another 5 meters, so that would be 10 meters. And then at 3 seconds, he had traveled another 5 meters, so that's 15 meters. And we want that to be our total displacement. So we have reached our goal here. And so then we are going to now fill out our velocity time graph. So we know that he traveled, or the bicyclist traveled for 3 seconds. He was traveling at a velocity of 5 meters per second. And we don't know if they started timing from when he was stopped. All we know is that he was when they started timing, that he was traveling at a velocity of 5 meters per second, which is why this is not 0. Okay, so let's go ahead and make our position time graph. Our time will be 1, 2, 3, 4, 5. And then for position, let's do by 5s. Perfect. So I did this in blue. We'll do 0 at 0. 1 second was at 5. At 2 seconds, he was at 10. At 3 seconds, he reached 15. Okay. And then we'll do 1 here, 2, 3, 4, 5, 6 seconds. We'll do, I guess, 5, 10, 15, -5 here, -10, -15, and this will always be 0. And at 0 seconds, he was traveling at 5 meters per second. At 1 second, he was traveling at 5 meters per second, 2, and 3. So then he gets a straight line through here, and he gets a straight line through here. So by now, this is what our worksheet kind of looks like. Oh, we should probably also do our motion map. So this is our position line, and we're going to mark our position line with the positions. So 5 meters, 10 meters, 15 meters, 20 meters, 25 meters. And based on our information, he was at 0, 0, at t equals 0. And then he moved to 5 meters. After 1 second, he moved to 10 meters after 2. And he reached 15 meters at time 3. Perfect. Okay, let's see here. Let's go ahead and look at B. At what speed would he travel to cover the same distance in 6 seconds? So let's pick a different color. I'm going to pick green. So that means at 6 seconds, he traveled from 0 meters to the same ending, which was 15 meters. Now, we have to figure out, how did he get there? Or how do we fill in the boxes, right? It might help to first fill out our velocity. So our velocity is equal to our final position minus our initial position, our final time minus our initial time. So which is going to be 15 meters minus 0 meters over 6 seconds minus 0 seconds. So essentially it's going to be 15 meters over 6 seconds, which is 2.5 meters per second. So this was how fast he was traveling. So we'll go down to the velocity. And for that whole time, let's just write our units here. He was traveling at 2.5 meters per second. So every second he's traveled 2.5 meters. So that means from 0 to 1 second, from 0 seconds to 1 second, he traveled 2.5 meters. And then he added another 2.5 meters, so then he would end up at 5 meters. Okay. And so this is how our table would look like for position B. So in filling out our graph, he was at 0, 0. And then at 1 second, he was at 2.5 meters. Oh. At 2 seconds, he was at 5. At 3 seconds, he was at 7.5. At 4 seconds, he was at 10. And at 5, he was at 12.5. And then 6, he was at 15. So that's how I would fill out the position time graph. And then the velocity time graph, since he was going at 2.5 meters all the way through, I would just draw my straight constant velocity line through there. And then we're going to make our motion map. If I can just make that larger. And so I'm going to do the same thing here. Make my position line the same as A. Okay. And so he started at 0, at time is equal to 0. And then he took 1 second to get to 2.5. And took another second to get to 5. And then to 7.5. Then to 10. 12.5. And finally, he reaches 15 meters at 6 seconds. So that's how to do that number 1 all the way up to proportional reasoning. And stay tuned for the proportional reasoning explanation.